Hi, Hawks.
Hi, Miss Lanigan.
Miss Lanigan here with you and my favorite camera person, Mr. Corbett.
Oh!
We are doing another inertia demo because we're trying to get you to figure out what inertia really is. And we've had lots of comments of people saying, well, it's gravity. Well, gravity plays a part in inertia, but there's something more to it. So the definition of inertia is something like an object in motion stays in motion unless acted upon by an unbalanced force. Something like that, right? Okay, so think about this. An object in motion stays in motion, but an object at rest will stay at rest unless acted on by an unbalanced force. Ready? Are you ready?
I'm ready! Oh, my gosh! Oh, wow. Round of applause, everybody at home. Give Miss Lanigan a round of applause right now. That was amazing! Wow, look at that.
So how is that inertia?
In Newton's first law of motion, objects that are at rest stay at rest, and objects in motion stay in motion at a constant speed and in the same direction, unless acted upon by a force. The first law is also known as the law of inertia.
The inertia of an object remains the same unless a force acts. So if something is at rest, it will stay at rest unless a force acts. If it's moving, it will stay in motion in a constant way unless a force acts.
A hockey puck sliding across the ice follows this law.
If you watch the hockey puck moving with no one touching it, it goes in a straight line. If it was perfectly frictionless between the hockey puck and the ice, it would go on at the same speed forever.
If you were in space, a vacuum where there is no air resistance, no friction, nothing acting on something, it will keep going in a straight line forever and ever and ever. So here on Earth, if I throw something, it's not going to go in a straight line. It can't go in a straight line. Gravity's going to pull it down. So it might seem like it's going, but then it's going to go down. And yeah, there's also air resistance. So something's going to slow down because of the molecules in the air, the friction created. So for us to understand inertia, you have to take into consideration force, acceleration, velocity, gravity, forces, net forces, all of this stuff that for sixth grade science, we're not going to worry about so much. We're going to just concentrate on things not moving and then a force acting on them that causes movement and gravity.
Hey, Miss Lanigan, what you doing there?
Oh, hey, I'm, between that and the smell of onions, we just a little barbecue. We're having a real good time here at Mr. Corbett's.
And it's so nice outside.
It's
Oh,
a
look
beautiful
at
day.
the sun is shining. It must be spring.
Yes. Okay. Hawks, do you remember the lab that we did? The demo that we did. One of these beakers is taller than the other one. Doesn't matter. We can make it work. We did a demo where we're talking about inertia, and we had toilet paper rolls over the beakers, and then put eggs on them. And I smacked the pan out of the way, and the eggs went right down into the beakers. Eggs.
Yes.
I found some eggs.
There are eggs.
So just a real quick reminder of how we did this last time.
Whoa!
Okay. So they fell into the water. They did not go flying with the pan.
Wow.
I can't get them out. I put too much water in. All right. Now I'm going to try the same thing. Looks like the dye came off into them. Same thing, but...
Going big. Go big or go
I've
home.
never done this before.
Okay,
but
this might end good or it might end terrible.
it should be the same idea, right? Because an object at rest will stay at rest. And the force, we've talked about gravity, right? Force of gravity.
Yeah, I think so.
Now, I think the trickiest part here is going to be to get these to balance in the first place without them falling over because it's so tall. Yeah, this is going to be interesting. Because it's okay. Wait, maybe we'll just do one at a time. Whoops, sorry. Because the beakers are not. See how the beakers aren't the same height?
They're not.
Maybe I'll just do it over one. Yeah, let's do that. It'd be way more impressive if we could put like 30 of them in a row.
Might want to move that other beaker though.
Okay, does that look like it's centered?
This looks like a giant sword.
We ready?
Whoa! All right, do it.
Oh, now I'm scared.
You can do it.
Okay, right?
Oh!
All right.
Nailed it.
We've figured this out that we just needed to put something underneath the lower one.
That is so scientific.
Took us a while to figure it out.
Check it out.
I want a pink one this time. Let's use this pink egg.
Yes.
Yeah, here we go. This one has a cute little sun on it. Okay. All right. Let's see.
You can do it. You can do it. Oh. And that's the demo.
Ta-da! It's balancing.
Look at that. That's amazing.
Okay, here we go. You ready?
You can do it. You can do it.
Here we go. Here we go.
Oh!
I hit.
Take 427.
Yes.
You can do this.
Okay, here we go. 3, 2.
Oh! Nailed it. Look at that.
I think let's do slow-mo.
Let's do it.